Hello viewers, this is Ronald taking you through the tutorial for O-level physics. In this video, we're going to talk about electromagnetic effects. So we shall start with question 1, and these questions are the very questions I left in the previous video, and I believe by now you have already tried them out and ready to mark yourself and check your progress. So we shall start with question 1. So question 1 came from UNEB 2010, paper 1, question 44, and part A says, what is a magnetic field? So here we shall see that a magnetic field is the space surrounding a magnet in which a magnetic force is exerted. So if you read that will be 1 mark. So now we shall go to part B. Part B says that figure 12 shows the lead of a cassette tape recorder. So this is figure 12. So Roman 1 says, explain why a current through the wire causes the tape to be magnetized. Why current through this wire makes this tape to be magnetized. So you come and say that the current magnetizes the core, and I believe by now you know that by electrical method, when you wound a wire around a material, a metal, that metal will become magnetized, or a magnetic material. So after the core getting magnetized, we shall say that the core then induces, know that word, induces its magnetism on the tape, and hence the tape is magnetized. So this tape is magnetized by induced magnetism. So basically that's what they wanted in Roman 1, and if you read that will be your 2 marks. Now shall go to Roman 2. Roman 2 says that the tape is usually made of plastic and coated with a thin layer of iron oxide. Then they ask, why is iron oxide used? So shall say that iron is a soft magnetic material, and I believe you know that soft magnetic materials are those which are easier to magnetize and easier to demagnetize. So iron oxide will be used because it is easily magnetized and easily demagnetized. So if you read that will be your 1 mark. So now shall go to question 2. Question 2 was got from UNEB 1993, paper 1, question 5, and Roman 1 part A says, state 2 factors which affect the strength of electromagnet. So 1 will be the magnitude of the current flowing through the coil, and 2 will be the number of turns in the coil. So basically that's what they wanted, and that's how you can get the 2 marks. Now shall go to part B. Part B says that the diagram above shows a small magnet placed near an electromagnet. Describe what happens to it when the key is closed. So this is a small magnet and it's placed near an electromagnet. So they want you to describe what happens when this key is closed. So when this key is closed, remember current moves from positive to negative, so current will move in that direction and back to the source. So when you do that, you realize that when you test polarity, if you look through this side, the direction of the current will be in a clockwise direction, meaning this is the south pole, and when you look through this side, you realize that the direction of the current will be in an anti-clockwise direction, meaning this is the north and this is the south. But remember, this is south, so we know that from the laws of magnetism, unlike poles, will attract. Therefore, here there will be an attraction because these are unlike poles. So now we shall come and say they want to describe what happens when the key is closed. In this case, we shall say that the end of the electromagnet closer to the small magnet becomes the north pole. I think we've already seen that when we tested the polarity. And since unlike poles attract, the small magnet will be attracted towards the electromagnet. So basically that's what happens, and that's how the two masks can be got. So now we shall go to question 3, and question 3 was got from UNEB 2004, paper 1, question 42, and part A says state two differences between AC and DC generators. So one of the differences we have said that the current in the external circuit of a DC generator is unidirectional, while that in the external circuit of an AC generator is bidirectional. In other words, the same as writing that an AC generator produces alternating current while a DC generator produces direct current. So you can either write this or you write that. That will be one of the differences. So the second difference says that in an AC generator, the brushes run on commutators which maintain a constant connection between the rotating coil and the external circuit, while in a DC generator, the brushes run on slip rings which reverse, that word reverse, the connection between the rotating coil and the external circuit for every half cycle of the coil. So basically those are the two main differences between an AC generator and a DC generator. So if you wrote that, that will be the two marks got. So now that was part A. Now let's see part B of the very question. So part B says that briefly describe what happens when a magnet is moved into a coil as shown in figure 8. So here we shall say that when the magnet is moved into the coil as shown, EMF is induced into the coil and current flows in the coil. This makes the pointer of the current meter to deflect in one direction. So basically that's what they wanted, and this is how you could get the 2 marks on that part. So that was question 3. Now let's go to the next question. So question 4 was got from 2002 of UNEB paper 1, question 43, and it says in a dam 2 exponent 3 kilograms of water falls every second through a height of 20 centimeters to operate an electric generator. Then part A, calculate the power input into the generator. First of all, you have to get the work input. So work input is equal to force times distance, and when I substitute force will be got by the weight. So this is the mg, weight, mass is 2 exponent 3, which is that. Then g is the acceleration due to gravity, and under the constants it is 10. Then the distance is this height but converted to meters. So this was centimeters, you have to convert to meters to get 20 over 100. So when I use a calculator, I'll come up with my work input as 400 joules. Now that I've got work input, I can get now the power input which they want by saying that power input is equal to work input over time taken. So work input was 400 joules and time taken was 1 second, as you can see here. That, and when I substitute, I'll come up with my power input as 400 watts, and basically that's what they wanted. Now let's see how much can be awarded. So half a mark will be for substitution, half a mark for getting the work input, another half a mark for the formula, half a mark for substitution, half a mark for the final answer. So basically that's how 2.5 marks could be got. Now we shall go to part B. Part B says that state the energy changes which take place. So first of all, potential energy changes to kinetic energy, and kinetic energy changes to electrical energy, then electrical energy changes to sound and heat energy. So half a mark for changing from potential energy to kinetic energy, half a mark from kinetic energy to electrical energy, another half a mark for changing from electrical energy to sound and heat energy. So basically that's how 1.5 marks could be got in that part. So now we shall go to question 5. Question 5 came from UNEB 1987, paper 1, question 1, and it says that 1000 kilograms of water falls through a height of 15 meters every second to operate an electrical generator. Part A, they say calculate the power input to the generator. So first of all, you have to get the work input, which is equal to force times distance, and that forces will be equal to the weight. So weight is mg, where mass is 10,000 and g is 10. Then the distance was 15 meters, so you come and substitute there. And when I use the calculator, I'll come up with my work input as 1.5 exponent 5 joules. Now that I know the work input, I can get power input from work input over time taken. So when I substitute, I'll come up with that, and when I simplify, I'll come up with my power input as 1.5 exponent 5 watts. So basically that's what they wanted, and now let's see how much can be awarded. So half a mark for that, 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 and full mark for that. So basically that's how the 3 marks could be got. So now we shall go to part B. Part B says that give any 2 possible reasons why the efficiency of the generator is less than 100%. So one of the reasons is that the frictional forces in the moving parts of the generator reduce its efficiency. Another one is that the resistance in the windings of the rectangular coil reduce the output voltage, hence efficiency. So basically that's what they wanted in that part, and that's how you could get the 2 marks. So I believe you have marked yourself and checked your progress. So what I'm going to do, I'm going to leave you with another set of questions still under the same topic of electromagnetic effects. So that brings us the end of this lesson. Thank you for watching, and be reminded the solutions for the assignment left will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the video with the solutions has been uploaded. Otherwise, if you also know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.